By applying the concepts of addition and multiplication, you can describe such a line mathematically. So let me now show you how you can understand linear functions. A function is a made-up machine that starts to run as soon as it gets fed a valid input. This input is often a number, for example, a 4. The machine then takes this input, processes it, possibly modifies it, and creates an output, for example, a 13. Now, whenever you feed this particular machine the input 4, the output will always be 13. Functions work in a repeatable way. So, if you plug in the same input, you will get out the same output. We usually note down this transformation of an input into an output in one of these two ways. In the second version, the name of the function, f, is given as well. At the moment, our example function is a black box. So let's open it up. It takes the input value, multiplies it by 2, and then adds 5. So for an input of 4, the output will be 13. For an input of 10, the output will be 25. We call such a machine that consists of a multiplication followed by an addition a linear function. There you have it. You finally understand what a linear function is. If the input is a real number of choice, denoted by the variable x, the multiplication by 2 gives 2 times x, and the subsequent addition of 5 results in 2x plus 5. Note that multiplication goes before addition. Therefore, we do not need brackets here. Note that the multiplication symbol between a number and a variable can be dropped. The output is then denoted by f of x or y. This is easy to remember if you recall that the letter y follows the letter x in the alphabet. So, multiplication by a constant number followed by the addition of a constant number, that's what makes a linear function. We will now have a look at a few standard problems that often appear in exams and exercises. This is your exercise number 1. The linear function y equals 6x plus 3 is given. A. Calculate the output y for the input x equals negative 2. B. Calculate the input x which produces the output y equals 12. Pause the video now to solve the exercise and write down your results on a piece of paper. Here are the solutions to exercise number 1. This is your exercise number 2. The two linear functions f of x is negative 3x plus 5 and g of x is negative 4 plus 2x are given. A. Calculate f of 0 and g of 0. B. Calculate and compare f of 2, g of 2, f of 3 and g of 3. Pause the video now to solve the exercise. Here are the solutions to exercise number 2. The factor by which the input x of a linear function is multiplied is often written as m and sometimes a and is called the slope or gradient. The constant summand that is subsequently added is often written as q and sometimes b and is called the y-Intercept. In this video, I will use the letters m and q. Remember, we've started the video like this. A linear function is the multiplication by a fixed number followed by the addition of a fixed number. If you use x equals 0 as the input to a linear function, the multiplication by m will result in 0, and the subsequent addition of q will result in q. Therefore, the input of 0 to a linear function will always give you the output of q. Imagine you order X identical pizzas from your favorite pizza delivery. Yummy! Each for a price of M equals $11. Additionally, there's a delivery fee of Q equals $3. It makes sense to add the delivery fee at the end. You cannot add the delivery fee to X, because X is a number of pizzas, and not an amount of money in dollars. And that way, the delivery fee does not get multiplied by the number of pizzas as well. If you order x equals 4 of those pizzas, you get a total charge of $47. Let's now proceed with the next standard exercise on linear functions. By the way, if you're confused by anything in this video, just leave a comment below with the timestamp and your question. This is exercise number 3. Pause the video now to solve the exercise. Here are the solutions to exercise number 3 shown in red. We have now found out how linear functions are a combination of multiplication and addition. But why do they look like a line, how I claimed in the beginning? To find out, we will draw the linear function g of x is 0.5x minus 2 on a coordinate system. Let's input arbitrary x values into the function and calculate their corresponding outputs, the y values, and then draw the resulting points x, y onto the coordinate plane. For every point, you start at the correct value on the x-axis, and from there you move up if y is positive, or down if y is negative. By using a ruler, you can now draw a line through all calculated points of the linear function. That's why the word linear sounds similar to the word line. Now have a look at the intersection point of the line with the y-axis. The y value at this point is called the y-intercept q. So q is -2. Now choose an arbitrary point on the line, for example, the point P at -4, -4. If you now move 1 unit to the right from there, the y value on the line will increase by 0.5, which is given by the slope m of the linear function. If you instead move 4 units to the right, the y value will change even 4 times as much, which is 4 times 0.5, which is 2. That way, you can easily find new points on the given line, as for example point Q at 0, -2. The resulting triangles are called slope triangles, and they always have the same shape for a given linear function, even though they are different in size. In the given example, the slope triangle is always half as high as it is wide, which we can also verify for a width of 10. So, give this final, challenging exercise number 4 a try. It is a typical exam question on the topic of linear functions all over the world. Subscribe this channel if you need to study other math topics in the future as well. NEO tells you that the linear function f passes through the 2 points A at 3, 5 and B at 7, -1. Can you calculate the equation of function f for NEO? Now pause the video to think about the solution. Here are 2 useful methods to solve exercise number 4. By studying this video, you're now able to solve standard problems on linear functions. If you have enjoyed it, consider giving it thumbs up. So, good luck with your linear functions. I'm confident you can tackle them. Stay tuned for a decent summary on rules and formulas on the topic of linear functions. Subscribe The Way of the Mathematician now if you need to study other math topics in the future as well.